the last video, that is chapter 9, I have described all the relations among displacement, velocity, acceleration, their representation in graph, and the required information that you will get from the graph and converting into the real equations that I have taught. Now, in this chapter, in the chapter 10, I will first explain the average speed, average velocity. The average speed is the total distance by total time. So that means if any object or person is moving along a straight line and it is, let's say, in t1 time moving s1, t2 time moving s2, t3 time moving s3, and so on, then their average speed would be the total distance moved by the total time for each case, t3 and so on. So this will be the universal or general representation of average speed. This is speed. Okay. Now, if we say the displacement, then the thing will be little change as in case of velocity. Sorry, if I say the velocity, what is average velocity, then in this case the thing will be little change. If it is moving in the same direction, then it will be followed the same equation, means all the different displacement by that all time. So the formula will be total displacement by total time. The things will be seems to be same, unless and otherwise the motion is changing its direction. That means if it is moving in the same direction in a linear path, then speed and velocity of any kind of speed and velocity, that is average or the speed itself with the velocity, will be same. If it is changing, let's say I am considering some condition where it has moved a distance, let's say s this side, s1 this side, from starting from A to B and coming back again with a distance of s2, then the ultimate displacement means where it is reaching C, so ultimate displacement will be AC, so that will be s1 minus s2. So for displacement we will use the ultimate distance between the initial and the final position of the object that is moving, and the total time, that the time will be t1 plus t2. It's the time, it is not be deducted from each other, because whatever be the displacement, we are assuming that is due to the any motion, and the motion is, it is done for t1 time it has moved s1, and it is for t2 time it has moved t2 s2. So this total time taken for this displacement will be t1 plus t2. So your total displacement upon total time. So this will be the difference if in case the change in direction. So just keep it in mind, there is nothing more. If it is they are moving in the same direction, then this average speed and velocity will be same. If direction change, speed will be same as it is as the earlier, but displacement will be the, you have to take the actual distance, the straight distance, the shortest distance between the initial and the final position, and then after you have to divide by the total time, that is the time taken for moving different segment in that motion during the total travel. Okay, understood? Okay, good. So now I will bring some specific condition, and on that some specific formula you can arrive at. So the first of such case number 1, you can say case 1, where a particle is moving from A to B with the time of s1 distance to the time of t1, and from B to A, so that is this will be the speed I am saying. So that can be represented at, let's say, v1, because it is linear, so v1 in same direction, v1 and speed can be taken as 1, and while it is moving from a to b, while moving from b to a, that is changing its velocity or speed, and the time taking is t2 to move the same distance. So my assumption is that AB, the distance is x, let's say. So as per the formula, the average, so I will assume it S average, so that means speed average will be the total distance. The total distance is x plus x, because x is going this side, x is again coming back, by the total time. For time taking for this is t1, and time taken for going back plus t2. So it will be the speed. So that is 2x, and now time, can I be able to represent with the terms of x and v? So time for t1 when it is moving a to b, it will be the x distance divided by the velocity v1, and that is for t2, it will be the x distance divided by v2. So if I put it here, so x will be x by v1 plus x by v2. Understood? So now for the, if I calculate, it will be 2x divided by x if I taken common, so v1 plus v2. So this is x can be cancelled out as x not equal to 0. If x is equal to 0, that calculation doesn't have any meaning, because it is not moving, it is at rest. So I cannot calculate anything, so speed will be 0 there. So if I calculate the v1 v2, which is come as the LCM, will come at the top, and it will be v1 plus v2. v1 to v1 v2 divided by v1 by v2. So that is the average velocity when it is moving from a to b with the velocity v1 at a time of t1, covering that distance, and on return it is covering the same distance with v2 with the time of t2. So in that way the average velocity will come this. Okay, the average speed or velocity. Why I am saying velocity, when it is moving from a to b, their velocity doesn't change and it is moving in the same direction. Well, for that journey when it is moving from a to b, but while moving b to a, that is also maintaining the same velocity with the same direction. But if I consider the whole journey of that, in a whole journey, that average, the average, I cannot say it is a velocity, rather I have to say it is a speed. But because in if I consider the overall journey of the person or particle, if it is going from a to b and then again from b to a, so in this case, if I want to consider the v average, that means velocity average, so I have to consider the total displacement. So in that case, the total displacement will be x, and while it returning, it is changing the direction, so x minus x will come, and total time will be t1 plus t2. But whatever be the value of t1 and t2 plus t2, whatever it is there, but the top one is 0, and that is divided by t1 t2, that will be 0. So average velocity during the movement, when it is returning back and coming back, so when somebody has told to calculate the average velocity of the total journey, then that case it will be, the average velocity will be 0. But average speed, as because it doesn't depend on the velocity, does not depend on the direction, so it would become some velocity, some value. But v1 and v2 individually, if we say, they can be considered as a speed or velocity, because the individual movement, individual journey from a to b, if I specifically say, that is considered to be and have direction and the value on the same direction. So it is not changing any direction during movement from a to b. So individually, if in the problem it is said that the velocity towards moving a to b is v1, so you cannot take it wrong, as because that if it is said that for the total journey you have to consider the v average, so that there the v average will be 0, because we have to consider the total displacement, and in this case that initial position and the final position, the total displacement is 0. So just concentrate how I am doing, what are the things I am telling. So it may like that, don't confuse, because you just concentrate the theory and the definition of the certain things. Okay. So in that case it is a specific case, but you just remember for the whole journey, S average has to be this one. V average has to be 0. Okay. So moving to the next case. Case 2. Case 2 is that the same, moving from A to B. Let me take another color. Now this time again the point are same, A to B. There some particle is moving. Half of the path, that means the middle, let's say I am denoting as M. Middle of the path, up to that it has moved with a velocity u, and half of the path with the velocity v. So in this case, what will be the average speed and average velocity? Okay. So as because it is moving on the same direction, in this case it is moving with a velocity up to middle, then after it is changing. So this is non-uniform velocity, but it can be considered as a velocity because the magnitude is there and the velocity and the direction is same. So it is not changing velocity. So in this case both will come. Okay. So if I consider the average speed, S average, as per the formula, I have to consider the total distance by total time. The total distance this case is this is half. If I consider this is 2x, so for this case I am considering AB is equal to 2x. It will be easy for me to calculate. So the half of the case means x. The total is 2x, so 2x is the total distance, and the time for this first half will be the distance upon the velocity. Okay, and for the second case the same distance upon the velocity. So in this case 2x and here if I take x common, it will be 1 by u plus 1 by v. It is somewhat going similar way than the earlier. This will be because x not equal to, you can cancel out x on the numerator denominator. So ultimately it will come u and v on the numerator. Here will be v plus u. So the amount of the value is coming the same as the earlier, but in that case the displacement, the journey was from A to B and B to A again, but this case half of the journey is made by velocity u and the half of by v. So in this case average speed I am getting the same. Now let's see if I am to calculate average velocity. So what would be the case? Here the velocity is u for the half of the case. So this is total displacement. The total displacement is x plus x because it is moving in the same direction. The final up to the final, the total distance is x, and the below the time is same. The time is value will be same. It is u plus 1 by v. So in this case also I am getting the same value. So you can understand the difference between the earlier case and this case. This case they are moving in the same direction. Half of this with u, half of this with v. So in this case the displacement also equals to the distance traversed. So in this case the average velocity and average speed will be same. Okay. So moving to the third example or third condition or case, you can say, because these are specific case. So in this case let's say case 3. In case 3 distance is same, the points are same, A to B, distance let's say 2x. So up to the half time. Now this time let's say the total time is 2t and total distance, let's say, because this is not said the half distance, so total distance is x. The half of the time means if it is 2t is taking, the half of the time is going with the velocity u, and the next half going with the velocity v. So then if I want to calculate s average, the total distance x, total time is what? Time has to be represented with the given condition. Given condition is that time is not given, only thing is the half of the time set. So if I say half of the time, this is total time has to be 2t, but the distance, distance is not set, velocity is set, time set. So I have to consider the total distance is x. So the total distance is a sum of two distances. How that two distance will come? The first distance covered with the velocity u, so u into t, and second distance x2 is covered by v, so v into t, because time they are utilizing half. So with the half they are moving with the velocity u, so distance travels x1 x2, so x1 and x2 are not same because the velocity is different. So now x1 if I put in the value of with the terms of this, so this will come like this. So if I take t common, it will be u plus v, and on the bottom it is t can be cancelled out as, we can say, the argument is that t cannot be 0, otherwise there is no meaning of this journey and the thing will be in rest. So t 0 means they are at the initial point only. So ultimately this will become u plus v by 2. So now you can understand, when it is moving half of the distance with a certain velocity and then half the distance, when the distance is half, your thing is coming like that. When the time is half, your average speed is coming like that. Now if I consider the average velocity, let me check it whether it is coming same or not. So as per the formula, it is total displacement same and total time. As the things are same, so the value will also come same. So in this case also, so the velocity and the speed, average speed is same. So you have to keep in mind, when the journey is towards the same direction, there is no return back of any distance. So there the thing of average speed and average velocity must be same. So when direction is same and there is no return back, so then the average speed and the average velocity will be same. So these are the three such conditions where you would definitely get a numerical means some relation which can be used directly. You need not to calculate it again and again. It is a, you can say, the empirical one. Moving to next. There are some may say the sub concept. There are one term that is called deceleration. Basically, deceleration is the anti-acceleration, you can say, anti-acceleration. How it is anti-acceleration? Because acceleration is the final velocity minus the initial velocity by the time between which the velocity attained from initial velocity to final velocity. Okay. Now this is very simple. Now deceleration is the just reverse. If I consider as the deceleration, so that can be said when I'm considering deceleration. Let's say I am just denoting by d. So it is by definition is the when the acceleration is reducing. So acceleration is by this definition cannot be reduced because v is always u, greater than u. But if it is reverse, then when the deceleration is calculated, so as per the thing, if v is greater than 0, I am getting deceleration. if I am considering deceleration, then that case v less than u. So if I put it like that, same, so this value is what the numerical calculation, after the numerical calculation, what value will get? Will get always negative, because if v less than u, so definitely u minus v will be greater than 0. U minus v will be greater than 0. So if I take minus common, this will be positive by 2. So this value, if I take the mod value, so this mod value and this mod value, if I take not that this value magnitude with both will be same. A and D will be magnitude wise both will be same. But thing is that this minus will be treated as the opposite, because acceleration and deceleration are the vector quantity. If mod A is giving this value and mod D is this value, when the condition applies that for this case v greater than u, for this case v less than u, so magnitude wise both are same. If two vectors magnitude wise same, but it is differentiated by a negative sign, so these are negative vectors. We have learned that these are negative vectors. So negative vector, those the magnitude are same but direction is 180 degree apart, opposite. So if it is acceleration, it is deceleration. So deceleration can be said as negative a acceleration. Okay. So basically, what does it mean? It doesn't mean that I am getting an opposite one another vector which is opposite to A. Is not that. Deceleration, if I consider in the same direction where the acceleration moves, so you can understand for acceleration, if it is moving this way, then velocity is increasing, and if I consider the deceleration in the same direction, velocity is reducing. This is the only meaning of that. It's not that if acceleration is moving this way, deceleration should move in other way. No. Theoretically, what I have learned as a negative vector, this implies this, but physically it means that if acceleration is moving this way, because when a particle is moving, whether it is moving with the acceleration or deceleration, the movement must be on the same direction. Only thing is that if u and v is related such a way that u, if it is greater than v, that means the initial velocity is constantly reducing, so this is deceleration. When u is less than v, that means the velocity is constantly increasing, this will be treated as acceleration. So you understand that concept. It is not that when deceleration told you have to take some consideration a vector it is opposite to acceleration. It's not that. The only mean is that if deceleration is happening, it is that the opposite direction to the velocity increment. Well, now if it is deceleration happening, so the velocity is increasing which way? This way. So velocity, when it is increasing this way, the deceleration is happening this way, and velocity if it is going in the same direction, then we'll got acceleration. So it is helpful when we solve the numerical problem. So this is the concept where you should not be conceived with the negative acceleration. Okay. The only thing is that you have to take such a way that when deceleration, then velocity vector we have to consider opposite. So deceleration always happening opposite to the velocity vector, because velocity is having incrementing value on the opposite side. Okay. So it can be other concept is that is it possible for a body moving with moving with constant deceleration can stop permanently once and can increase velocity further. Because as per the understanding, when a particle is moving with the velocity, moving with the deceleration, that means the velocity from the initial condition constantly it is reducing. So if it is going like that, there must be some position, or so after some distance it must comes to a standstill. That means the final velocity must be zero. Definitely yes, because if it is something is reducing, so somewhere it will reach velocity v. But how come it can increase its velocity further? So if you say there is a hindrance, okay, it is constantly reducing, and before it hits, it having some reducing velocity, and when it hitting, it is instantaneously stop itself. But the total momentum, because this mass having some, because I'm not considering the force, so you can say only if I take the velocity, so after it hitting here, it will not, that it will, if it is elastic body, it will not stick it to the wall, it will definitely will change its direction and move this way. When it will hitting the body instantaneously, at point of time, the velocity will be zero, because it is changing velocity. So in that point, when it is hitting, but some point of time or instantaneously, that velocity will become zero. It may be something tending to zero, the time is very small, but for time also. But after the hitting, what will happen? It will change its direction. Now if it is changing its direction, then definitely what will happen? It is moving, that means from the stand, from the velocity it is reached zero, it will gain some velocity, otherwise cannot move. It after hitting, it will be stand still there. If it is moving some other direction, it must have some velocity. So in that case, it is incremental velocity, because the minimum what can it achieve? It is zero, it is already zero. And when it is rebounded and moving otherwise, so it will be a velocity zero. So that means when it is decelerating, it will be zero, and then after it will be accelerating. Okay, it can happen. Or if I say, if I say a similar thing, if a body is there, on the body is thrown from a ground, okay, so it is thrown from a ground, that means it has started with the initial velocity u. After reaching the maximum height, it must attain the velocity zero. Then after it has started moving downward. Okay, so when it is moving up, it is reaching u to zero, so that means decelerating. When it is moving back, that means it is again gaining velocity, that means accelerating. So this is the condition, this may happen. So this both case, it could be a possibility. When decreasing velocity, at point of time it will halt, and then after it will come back again with a velocity that is incremental in nature, that is accelerating. Okay, so this is the end of the theory and the concept study. Then after we'll move to our numerical part. If not, I am forgetting anything. Yes, I am not forgetting anything, it's okay. So Okay, so let me start with some problem so that I can continue in the next class also. So the first problem is saying a car moves on a circle circular path of radius r. Find the distance traveled by the car when it moves from a position I will show in the drawing. Let me finish the uh, sound first, the description first. From a position A to position B and displacement in each of the case shown in figure. So the two figures are shown. Figure 1 where the movement is from A to B and this is right angle. Another case it is diametrically opposite A to B. This is first case, this is second case. Now let me read it out again. A car moves on a circular path of radius r. This is having the radius, so I will take it radius equal to r and find the distance traveled by the car when it moves from position A to position B and displacement in each other. So both things you have to calculate, distance and displacement. So the both the things you have to calculate. Now consider the first case. So the first case, the theta is how much? This is 90 degree. So 90 degree is how much in radian? It is pi by 180 into 90. As I said, any degree can be converted into radian by pi by 180 if I multiply. So this is also degree, so it is 2. So this becomes pi by 2. Okay, the first part is over. So what is A to B? The arc length. So A to B arc length, that is our distance, because in the path, this is the path the particle is following when it is moving. It is a circular path. Okay, so the actual distance moved by AB through AB arc is, what is that? We know r into theta, radius into the angle formed during the movement between the arc, whatever the angle it is formed by the arc of movement. So it is equal to r into theta. So r is equal to capital R, theta is equal to pi by 2. So this is your displacement for first case. Whereas if you take, this is case 1. If I consider the second case, the same arc, it has moved the theta, that is equal to 180 degree. So in that case, theta would be, r would be same, radius r, and theta would be pi by 180 into 180, because this has moved two of 90 degree, that means 180 degree. Here it is 90 degree. So 180 degree is nothing but pi. So it will be r into pi, case 2. So the both case distance is calculated. Now I have to calculate the, what is that? The distance is calculated. Now displacement has to be calculated. So case 1, displacement. What is the displacement? When I add these two, so this will form a right angle triangle A. If it is a O, then AOB is the right angle triangle, and the hypotenuse will be the displacement. So the straight length AB will be given by under root of AO square plus OB square. So what is AO? AO is radius, OB also radius. So this is under root of r square plus r square, that is equal to under root of 2r square, that means equal to root 2r. So the displacement for first case is 2r. Now consider the displacement for the second case. For second case, displacement will be how much? A to B. A to B is nothing but 2 into radius, means diameter, because this point are diametrically opposite. So this will be the straight way you will get the displacement. So it is very easy, but even I have calculated, it can be easily be understood. If you just follow the video and practice at home, you can able to understand. So up to this for this video. In the next video, I will come and I will solve the problem for number 2 and onwards. Okay, thank you.